एक बार 12th एंड 13th क्वेश्चन सॉल्व करो, उसके बाद मैं एक्सप्लेन करता हूँ। Done? So let me explain. In this question, you have rate of dissipation of heat by black body at a temperature T is Q. What will be the rate of dissipation of heat if temperature is 2T and emissivity is this? So there are two factors. One, black body, temperature T, heat. Second, not black body, so not ideal condition. Emissivity is 0.25 and temperature is increasing. You should know which formula we should use here. Okay. So, example, question number 12. So, if you solve this question, you know formula for the heat dissipation will be equal to emissivity, sorry, T emissivity. This sigma T is powerful, correct? And this is the heat per unit time per unit area. So this is the formula of the energy per unit area per unit time is equal to E sigma T raised to power 4. And this is known as Stephen law, correct? Do you remember we discussed this in the class? Second, yeah, this is the main formula. So you have two options. In first case, you have black body, and in case of black body, E value is equal to 1. Okay. And second case, you have same body, but emissivity value is already given 0.25. So what will be heat per unit time per unit area will be equal to E value 1 sigma temperature is T raised to power 4. In second case, emissivity is 0.25, it means 1 by 4 sigma temperature is 2T raised to power 4. You have to calculate what is the new heat. So you can take ratio of both equation 1 and equation 2. So what is the value here? 1 sigma T square and multiply 2 raised to power 4 is 16. And here sigma T raised to power 4 sigma 2 cancel 4. So what is the new heat? 4 time of the old heat. Tell me, do you have any questions? We discussed this formula in class, correct? We discussed this formula in class, and this is the only formula you need in this topic. Yes or no? Right? Even in the second situation, formula will be exactly same. Energy per unit time per unit area in 13th question is energy per unit time per unit area is E sigma T raised to power 4. You have to calculate it. Now using this formula, solve question number 30. Question number 13. Chandra, you have network issue?
Yes, sir.
You have Wi-Fi, right? In your house.
Yes, sir.
Okay. Yeah. Question number 13.
सॉरी सर लेट हो
So,
गया थोड़ा
कोई बात नहीं. अभी हमने ये क्वेश्चन सॉल्व किया है क्वेश्चन नंबर 12 and if you calculate your rate of dissipation of heat, actually rate of dissipation of heat is energy is equal to energy per unit time. And if you use Stephen Boltzmann law, you know actually it is energy per unit time per unit area is equal to emissivity, constant value and T raised to power 4. तो याद रखना सभी लोग this is the actual formula you use in Stephen's Boltzmann law. Right? Same method you have to apply in question number 13 and solve. Repeat what is the answer. Arpit, explain me कि what is given in the question. क्या दिया है इस क्वेश्चन और निकालना क्या है? क्वेश्चन नंबर 30. अर्पित, मेरी आवाज आ रही है? सानिया,
यस
टेल
सर।
मी व्हाट इज गिवन इन दिस क्वेश्चन।
सर टेम्परेचर का इंक्रीज दिया हुआ है बाय 10%।
ओके,
और
व्हाट वी हैव टू कैलकुलेट, क्या कैलकुलेट करना
सर एमिसिविटी कैलकुलेट करना है।
है? एमिसिविटी कैलकुलेट करनी है। चेंज इन द एमिसिविटी कंपेयर टू द ओरिजिनल, दिस इज व्हाट वी हैव टू कैलकुलेट। आगे जब हम बोले ना परसेंटेज इंक्रीज इन द क्वांटिटी ऑफ रेडिएशन एमिटेड फ्रॉम इट्स सरफेस, so we have to calculate percentage of the change in emissivity. So कैसे निकालेंगे? New emissivity minus old divided by the new one. Correct? In the form of percentage, then you will get the answer. Multiply by 100 because in percentage. This is what you have to calculate. You can take E as such, E, original. First, you have to calculate what is E dash, and based on that, you can get answer. मैंने already सारी चीजें बता दी है, अब बस तुम्हें कैलकुलेट करना है। Remember, that is absolutely fine if you are not able to solve question, but you have to attempt. That is the purpose of the class. कि you attempt each and every question if you are not able to get enough time in home and not able to solve all those questions. During this class, we will solve each and every question, especially in physics. ठीक है? तो remember, कोई भी क्लास मिस कर देना, कभी भी फिजिक्स की क्लास मिस मत करना, चाहे कुछ भी हो जाए। It is fine if you miss any other class like chemistry or biology, but never miss physics one, because this is where you will learn during the class. If you don't do anything in home, I will teach from scratch. Okay, so here temperature of ideal gas increased by 10%. What is the change in the radiation emitted per unit surface? Now you know there are two things. Here you are calculating heat per unit time per unit area, which is equal to emissivity. Okay. So emissivity is equal to E sigma T raised to power 4. And in this question, you have black body. So Arpit, what is the value of E in case of black body?
1 1.
1. Anvita, if it is 1 and you are increasing radiation by 10%, what will be the change in the temperature? New temperature. Anvita, 1.1 time of the temperature or the temperature. Why? Because initially it was 100% temperature. 1. Now you are adding 10%. So what is the value? Already it was 1, now zero point 0.1, so 1.1. Yes or no? Increase in
Yes sir.
temperature by 10%.
Yes sir.
Correct? So if you are taking 100% divided by 100, divide by 100. This is 1. This is 1 by 10. So 1.1. So what will be new emissivity? E is same material, sigma is same. Temperature will be 1.1 time of the original temperature. Now you can use calculator and calculate what is the E sigma. 1.1 is the power 4. What is the answer?
1.46.
1.46. Okay. So this is 1.46 t raised to power 4. So can we say E dash will be 1.46 of E, correct? So emissivity will increase because change in the temperature. If you have calculated this emissivity, what you have to do? Put formula. Percentage of change in the emissivity is B. E dash minus E divided by E dash multiplied by 100. What is the new emissivity? 1.46 minus E. 1.46 by E, right? So E will be cancelled, multiplied by the 100. Right? So what will be the value? Put the value. What will be the value? 1.46 minus 1, it will be 0.46. Correct? Yes or no? Multiply by 100. 46%. You will ask her how you calculated this. And my answer is E dash value is 1.46 E minus E divided by E. 1.46 minus 1 is 0.46 E divided by E. E cancel. It is 0.46. Multiply by 100 because in percentage, so 46%. Tell me any doubt. So in this question, you have to take care of two things. One, key, when you calculate change in the emissivity, what should be the value? Doesn't matter. Acha, Chandana, if I'm calculating fraction, how do you calculate fraction? Chandana,
Sir,
how do you calculate fraction?
सर वो 1.46 माइनस 1 बाय 1.46 होना चाहिए ना.
yes, sir.
नहीं.
E dash value is 1.46 E inverse.
No, but here we have E value now. That is why I was asking you, Chandana, ki if you have to calculate any fraction, how do you calculate? Change in the value by original value. And
Yes,
if you calculate fraction percentage, then multiply by 100, right? What is the change here? And new emissivity minus old emissivity by old emissivity multiply by 100. I think by mistake I mentioned T dash, right? It is like fraction percentage, nothing else. And this is the formula of fraction percentage you use in unit and measurement. Like in error, you use almost everywhere in stress, strain. You use the same method, right? Fractional change in value by original value. The fractional change percentage multiplied by 100. Yes or no? So Sania and Chandana, you were right, but formula is change in the value by original. Original, correct?
yes, sir.
Yes
Any
sir.
doubt?
No sir.
Anvita and Arpit?
नहीं सर.
No. Question number 14, so direct repeated question. Two sphere have radii ratio this and density ratio this and same specific heat are heated to the same temperature, delta T value is also there, left in the same surrounding. So overall change in temperature is same. Rate of falling of temperature will be in the ratio of. Make it fast.
Sir, option 2.
Option 2. Try once again.
सर 2 यार है ऑप्शन 2 यार.
Okay. Answer will be 2. How, guys? First, you will see what is the ratio of the radius. R1 by R2 is equal to 1:3. Then density rho1 by rho2 is present in the 3:1, right? Both have same specific heat capacity. Now you can calculate volume, correct? Volume will be 4 by 3 pi r cube, right? 4 by 3 pi r cube, correct? And you can calculate example for sphere. This is the volume. The volume for the second. Hello guys, am I audible?
Yes, sir.
Yes,
हाँ,
sir.
got it. You will ask कि सर आप ये कर ही क्यों रहे हो? आप तो बताओ हमें करना क्या है कि tell me what is exactly we are supposed to do. Answer is we are supposed to apply Newton law of cooling. This rate of falling of temperature will be in the ratio. That is the rate of change in temperature with respect to time. This is what we have calculated. Okay. And how this rate of cooling depend upon the different values. It directly depend upon the area and inversely depend upon the mass. Correct, Arpit?
यस सर, पर
It,
स्पेसिफिकेशन तो कर रहा है ना, इनवर्सली प्रोपोर्शनलिटी।
हाँ,
सी भी लिख,
directly depend upon the area and inversely proportional to mass, ना?
mass and C also।
नहीं, but C is same, ना?
हाँ हाँ।
Specific heat capacity is same. So this is the formula, guys. This is important key. How to apply formula? What is the main formula? Formula is this: rate of falling of temperature will directly depend upon the area. More area, fast cooling. More mass, less cooling. Example: if you have 200 kg hot container and if you have 1 kg hot container, which one will cool down fast? Anvita, दो कंटेनर है हमारे पास, एक जिसका 200 kg मास है, सेकंड 1 kg, कौन सा बहुत जल्दी कूल हो जाएगा? Which one will cool fast?
1 kg.
1 kg, because less mass, fast cooling. Makes sense? So that's why even if you don't know this formula, you can directly correlate. More area, fast cooling. More mass, less cooling. So inversely proportional to the mass and directly proportional to the area. Now here you have area because in the form of radius you can calculate. Area is equal to pi r square. Right? What is the area of 4 pi r square? Na? For sphere. Chandana, what is the formula of sphere area? 4 pi r square, na?
Yes, sir. 4 pounds.
So by this you can calculate area. Point is how to calculate mass. You know density is equal to mass by volume. So we can calculate mass by multiplying density into volume. Okay. So if density and volume is given to us, so what we'll do? It directly depend upon the area and it also depend upon the density and volume. Area is given in the form of r square. Density ratio is given. You have to calculate volume ratio. V2 value is 27 times of V1. Okay, you have to take ratio now. You can calculate this. Got it, or should I explain this again? What was the question number? Rate of change in the temperature directly depend upon the area and inversely depend upon the mass. You know density is equal to mass by volume, so mass will be density into volume. So it will be area density into volume. What is the now you have to take a ratio of the, it's like delta T1 by dt divided by delta T2 by dt is equal to, what is the area here? Area will be in the form of r square, correct? So like r1 square, rho density and volume. What will be second r? What is the ratio of this radius? Radius is given in 1:3, na? So it will be 9r square divided by Density, new density is 3 times, correct? 1 by 3. And what is the volume? 27 times. So 9 3 is 27, 27 cancel out. Everything is cancelled out. It will be in the 1:1. Yes or no, guys? You have to write everything in the ratio form. Key area A1 will be equal to 4 pi R1 square. A2 area 4 pi R2 value is 3 times of R1. So 3 R square, it means A2 value is 9 times of A1. V2 value is 27 times of V1. And density rho 2 is 1 by 3 times of rho 1. You have to take ratio. Tell me, anybody have doubt? किसी को doubt है इसमें?
The density
अर्पित
is
तुमने
3 times.
जी 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 सर।
what is the ratio of density?
डेंसिटी दिया है।
Rho 1 by rho 2 is equal to 3:1 ना?
हाँ हाँ
So rho 2 value density, Chandana rho 2 density will be equal to rho 1 by 3 na?
Yes, sir.
Huh. So all the ratio are given, you have to take ratio. That's all. It will be 1. Why? Because 3 multiplied by 9 will be 27. Volume is 27 times 27, 27. Cancel out. Next question. Don't hesitate if you didn't understand. Just ask. Ki, sir, please explain me what is this. Same question. You can make it fast. Black body. Anvita, what is the emissivity value in black body? Anvita,
Yes, sir.
emissivity value for black body, E value.
1 day.
Hmm. So this is the wavelength and temperature is this. When temperature increases by 100 degrees Celsius, what is the intensity of emitted radiation?
सर ऑप्शन 2।
Option 2. Everybody got answer? Are you following Wien displacement law?
हाँ हाँ लैम्बडा एम टी इज इक्वल टू कांस्टेंट।
Lambda is inversely proportional to temperature. This is Wien displacement law. You have to calculate lambda 2. So can we write lambda 2 by lambda 1 will be equal to T1 by T2. What is lambda 2 value? We have to calculate. What is lambda 1 value? 5000. What is the first temperature? First temperature was how much? 1500. What is the second temperature? 2500. Right? So 2020 cancel. 5 3 is 15, 5 5 is 25. If you cancel out 1000, so it will be 3000. Guys, any doubt? Direct wind displacement law. If you are getting this question, it means you are lucky enough, right? Because direct question, wind displacement law. They can never ask anything from this except they are changing either wavelength or temperature, nothing else. They cannot twist question. Got it? Next question. Same thing is given. Wind displacement law. You have a black body. This is the temperature. Energy radiated by the body at a wavelength. This wavelength is energy this. At wavelength, this is U2 and this U3. Main constant value, I already given you this. Which of the following is correct? Which energy will be more?
Sir, option 4.
Option 4. How to calculate this same formula? Wavelength inversely proportional to temperature. And when you remove proportionality constant, you use D. This is Wayne displacement law, same law we use in the above equation. Wayne displacement law. So you can calculate what is the average wavelength because temperature is given. So how will you calculate wavelength? Wavelength will be B value 2.88 into 10 raised to power 6 divided by what will be the value of temperature? 5760. Correct? If you calculate wavelength, wavelength will be 500 nanometer at this temperature. At this temperature, wavelength is 500 nanometer. Correct? Now you tell me, if you increase wavelength, what is the impact on the energy? Because you know E is equal to h nu or E is equal to hc by lambda. Yes? Anybody have doubt in this atomic structure? E is equal to h nu or E is equal to hc by lambda. If you increase wavelength, what will be the impact on the energy?
Directly proportional.
Uh, So, if you see, in first case, wavelength is 250 nanometer, inversely proportional. Wavelength, directly proportional is frequency. If
ये आपने
radiation, क्या?
आपने क्या क्वेश्चन क्या पूछा था?
So what is the relation of wavelength and energy?
अच्छा.
Hmm. So, in this case, you have three wavelengths, 250 U1, wavelength 500 U2, and 1000 U3. Which of the following is correct? When wavelength increase, energy will decrease. Correct? So can you say wavelength increase U3 will be lesser than U2 and U2 will be lesser than U1? So is the answer 3? Tell me. Arpit.
सर जो U का वैल्यू लैम्बडा के सबसे पास होगा उसका वो वैल्यू ज्यादा होगा ना?
जो U का वैल्यू लैम्डा के पास हुआ कैसे?
हाँ एक कॉन्सेप्ट था ना.
हाँ,
हाँ,
कैसे?
याद नहीं.
हाँ, तो यही होता है ना, E is equal to h nu and E is equal to hc by lambda. And if you increase temperature, wavelength will reduce. Tell me, any doubt? So answer will be 3. U1 will be more than U2. U3 will be least. Yes or no, guys?
Yes, sir.
Uh, Respond. So I can understand whether you are able to understand or I have to explain in another way to make it easy. Got it,
सर
everybody?
Yes.
Uh,
सर
yes, Arpit.
ऑप्शन 3 नहीं होगा ना? मतलब
क्या?
ऑप्शन 4 क्यों नहीं होगा?
Because if you increase wavelength, then energy will decrease, right? That's the thing. Is equal to h nu is equal to h by lambda. Got it?
हाँ,
बस बताओ कोई डाउट? Next question. Solid at high temperature, wavelength of black body shift to the lower wavelength. Is this correct, Anvita?
Yes, sir.
Anvita, tell me which formula should I use in this question? Question number 70. Can I use this formula, Wayne displacement law? And can I use lambda is equal to b by 2? B is constant. Anvita,
Yes, sir.
so if you increase temperature, what will be the impact on the wavelength? Anvita,
Yes, sir.
answer. Assertion, is this assertion correct?
Temperature increases, wavelength will decrease, right?
Yeah, yes, it is correct. Second reason. Peak emission wavelength of black body is directly proportional to the temperature raised to power 4. Is this correct?
Sir, I think it's wrong.
no.
B said wavelength inversely proportional to temperature, not raised temperature raised to power 4. Temperature raised to power 4 is emissivity that directly depend upon temperature power 4. Wavelength inversely proportional to temperature. Okay. So first is correct, second is wrong. This is from next chapter. But you can still solve because PV is equal to nRT formula. Solve it. PV is equal to nRT. Write this formula. You have hydrogen gas. Okay. Pressure P. Temperature is given. Temperature, pressure. What you are supposed to calculate. Density you have to calculate. Instead of volume, can you write volume is equal to mass by density, right? Mass by rho is equal to nRT. And N is equal to mass by molar mass. This cancel. Can you say density will be mW pressure divided by RT? Yes or no? PV is equal to nRT. Volume is equal to, because we know density is equal to mass by volume. So volume is equal to mass by density. One. And N is number of moles. It is equal to given mass by molar mass. Okay. Given mass by molar mass. So this is the formula. Put value and tell me answer.
ऑप्शन 3. ऑप्शन 3.
Option C. Yeah. Molar mass 2, pressure 249 K, 10 is power 3, divided by what is R value 8.3, and what is the temperature 300. Correct? You'll get the answer. Correct? What should be the mass value? Not 2, sorry. 2 into 10 is power minus 3. Why? 2 gram. We have to convert into the standard unit kilogram. That's why 2 into 10 is power minus 3. Correct? So you will get in kilogram because unit is given in kilogram. Any doubt, guys? PV is equal to nRT. Simple ideal gas equation. Hmm. Hmm. Monoatomic gas volume is changing. Tanya, this question. What monoatomic gas pressure is this? Volume is this? Expand isothermally. Volume is this. Then adiabatically. Volume is this. What is the final pressure? For monoatomic gas, sigma value is 7 by 5. For isothermal, what is the formula, Sania?
Sir, for isothermal,
Hmm. All of you solve question because at the end of this session, I will see everybody's answer key how much you did during class. Remember this. You know PV is equal to nRT.
Sir, P1
When
V1 is equal to
temperature is constant, everything will be constant. So P1 V1 is equal to P2 V2. Any doubt, guys? And second, in case of adiabatic process, we did P P1 V1 gamma is equal to P2 V2 gamma, something like that. P1 V1 gamma is equal to P2 V2 gamma, correct? Because in adiabatic we use gamma term. Okay. So first you calculate this pressure. P2 value will be equal to P1 V1 by V2. What is the initial pressure? P.
B.
Initial volume V. Volume after isothermal process 2V. So this pressure is P by 2. Now in adiabatic, what will happen? Initial pressure is P by 2. Volume 2V gamma 7 by 5 is equal to P2. We have to calculate. V2 is 64, correct? 7 by 5. So what will happen? This P2 value we have to calculate. P2, P by 2, 2V divided by 64V, whole raised to power 7 by 5. 1 by 32, you will get answer. Here's the calculation. कैसे करें? Because 2 raised to power 5 is equal to 32. So 32 will be equal to 2 raised to power 5. Got it? Any doubt, guys? If you are confused, let me tell you how I did. Question number 19. In first situation, your pressure is P, your volume is V. Reaction undergo isothermal change, where temperature is constant. When temperature is constant, PV is equal to nRT. Temperature constant, so this whole value will be constant. So you will say PV will be equal to P1 V1. Then this will undergo adiabatic change. In adiabatic change, what happened? PV gamma is equal to constant. That's why P1 V1 gamma will be equal to P2 V2 gamma. You have to calculate what is this P2 value. Okay, how to calculate P2 value? Take V2 another side, P1 common, V1 by V2 whole raised to power gamma. Put values here. P value P, V value V, P1 value we have to calculate. P1 value was 2V. It is given in the question. VV cancel. P1 value is P by 2. How to calculate P2? P by 2. V1 was 2V given in the question. V2 is 64V given in the question. And power is 7 by 5. So V cancel 2 by 30. Correct? So P2 value is P by 2. You can write 1 by 30, 32, you can write in this way. 2 raised to power 5. 7 raised to power 5. So 5 will be cancelled out. Okay. Now you will take P by 2. 1 by 2 raised to power 7. You will get answer. Yes or no? Yes or no?
Yes, sir.
Any doubt? You will confuse ki what should I do if I have 1 by 32? 4 raised to power 7 by 5. To make it easy, you convert 32 into the power. And 32 is equal to 2 raised to power 5. 4 raised to power 7 by 5. 5 cancel. It will be equal to 2 raised to power 7. अर्थ आया था?
Yes, sir.
अनुविधा अर्थ आया था?
ಆಯ್ತು sir.
Very good. तानिया अर्थ आया था? तानिया
Yes, sir.
अर्थ आया था? तानिया अर्थ आया था?
समझी नहीं सर.
ये हमारी सीक्रेट लैंग्वेज है, हमने बनाई है अभी न्यू लैंग्वेज हमने डिस्कवर की है. अर्थ आया था मीन्स समझ में आया क्या, और उसका आंसर है आयतु. समझ में आ गया आयतु. तो अर्थ आया था?
आयतु सर.
हाँ. अर्पित अर्थ आया था?
यस सर.
से आयतु.
आई तो
हाँ.
क्वेश्चन नंबर 16 में क्वेश्चन
क्या?
नंबर 16 क्वेश्चन नंबर 16 में डाउट है अभी भी.
क्वेश्चन नंबर 16 में डाउट है, बिल्कुल बता देंगे. दिस इज हाउ guys you have to ask everybody. If you have doubt in the previous question, you can definitely ask. क्या डाउट है ask करके.
सर अगर लैम्बडा के वैल्यू मतलब
हम्म.
लैम्बडा में से छोटा होगा देन
हम्म.
वो इसको अब लेफ्ट साइड में जाएगा ना, जो इंच
अगर लैम्डा छोटा होगा तो
लैम्बडा मैक्स से देन एनर्जी डिक्रीज होगा.
एनर्जी डिक्रीज होगा अगर लैम्डा इंक्रीज होगा.
हाँ हाँ.
हाँ करेक्ट.
देन जो विंस डिस्ट्रीब्यूशन कर्व है उसका ग्राफ लेफ्ट साइड में जाएगा ना.
हाँ बट यहाँ
हाँ,
पे सी
इस
व्हेन
लॉजिक
यू आर
इस
व्हेन यू
लॉजिक
आर
से सर
इंक्रीजिंग वेवलेंथ
हाँ.
एनर्जी विल डिक्रीज ना.
नहीं, मैं भी जो
ये-
लॉजिक बोल रहा हूँ उस हिसाब से तो यूट्यूब बड़ा होगा इवेंट से.
बताओ. अकॉर्डिंग टू दिस सिचुएशन E is inversely proportional to lambda. Yes or no?
यस.
So if you increase wavelength, energy will reduce.
हाँ
So wavelength is maximum in third situation, 1000. Energy will be minimum. Wavelength is
हाँ
minimum in first situation, energy will be maximum.
हाँ
बताओ. Any doubt?
हाँ.
What is your point? बताओ अपना
नहीं,
point अगर कुछ.
यूट्यूब में मतलब एनर्जी सबसे ज्यादा होगा ना.
कैसे?
ये लैम्बडा में मैक्स का वैल्यू सेम है इस हिसाब से.
तो वेवलेंथ चेंज होगा तो एनर्जी चेंज हो जाएगी ना. कैसे है मैक्सिमम यहाँ पे?
नहीं जो ग्राफ है ना वो डिस्ट्रीब्यूशन लॉ में उस हिसाब से देखेंगे तो ऐसे ही
हाँ,
होगा।
ग्राफ में भी तो यही होता है ना कि इफ वी इंक्रीज टेम्परेचर देन मोर पार्टिकल विल हैव मोर एनर्जी, है ना। तो टेम्परेचर का तो रूल दिया ही नहीं है यहाँ पे, समझ गए। टेम्परेचर का रूल नहीं दिया है यहाँ पे। उसके बाद अगर तुम्हें लग रहा है कि सर ये ऐसे हो सकता है तो जरूर मैं चेंज करूंगा, क्योंकि देखो पॉइंट यही है कि अगर लॉजिकली तुम बताते हो कि कुछ पॉइंट है, तो मैं एक बार क्रॉस चेक कर लेता हूँ कि इसमें कुछ इश्यू तो नहीं है। ब्लैक बॉडी है at a temperature this, energy radiation emitted by wavelength is this, at wavelength this is this, and wavelength this is this, mean constant value is this, you have to tell which one is maximum. So Arpit, you are saying ki sir, at temperature 5760 we
हाँ
will have maximum energy, है ना, because this is matching when we calculate by this method,
हाँ हाँ हाँ
this method, this, correct.
हाँ
So if you calculate, this is the uh, maximum value.
हाँ
So here you will have maximum energy. Okay, got your point.
हाँ
Yes,
हाँ मैं
you are
बोला
right.
था। हाँ
मैं समझ गया तुम क्या कहना चाहते थे।
हाँ
Let me guy explain you. ये बोल रहा था, जैसे कहाँ पे एक्सप्लेन करूँ, यहीं पे कर देते हैं कि जब तुम कैलकुलेट करते हो वेवलेंथ विच इज इक्वल टू बी बाई टी, इस वेवलेंथ के ऊपर मैक्सिमम एनर्जी होती है when you take lambda and calculate this lambda value. At this lambda you will have maximum emitted energy, there will be maximum emission of energy at this wavelength. Okay, this is the maximum value, you will never calculate, you will never get value more than this. Okay, why? Because according to formula you write like this, lambda m is equal to b by t, this is the formula. Okay, and what is the meaning of lambda m? Here you will get the maximum value. What is the emission of radiation when it is maximized? So here you will always get maximum energy, maximum emission. This is what he said. Good point. Okay. Okay. So through this, when you are calculating, your wavelength is getting 500 nanometer. At 500 nanometer, you will get maximum emission, maximum energy. So this value will be maximum U2. All other value will be less than this. It means U2 is greater than U1. U2 is also greater than U3. सबको समझ आया? Everybody understood this concept?
यार E1 एंड U3 में कौन बड़ा है?
U1 and U3 में कौन बड़ा होगा?
हाँ
इसमें इसमें हमें फिर कैलकुलेट करना पड़ेगा।
ये ग्राफ से तो देख
वी
सकते हैं ना, मतलब
हाँ
अगर लैम्डा में से छोटा होगा तो लेफ्ट साइड में जाएगा, बढ़ाएगा तो राइट साइड में जाएगा।
हाँ नहीं, वो डिफरेंस देखना पड़ेगा कि एवरी टाइम यू आर इंक्रीजिंग बाय डबल, कि हियर 250, देन 500, देन 1000. Wavelength is every time increasing by double, right?
हाँ
एक इसका हाफ, एक इसका डबल है, तो there will be temperature will be, if wavelength less, temperature is more. It means U1 will be greater than U3.
हाँ हाँ
Okay.
हाँ।
कैसे पता चला? How did I get to know? कि if wavelength is less, then temperature will be more. And if temperature is more, you know emissivity is equal to sigma T raised to power 4. More temperature, more emissivity. Right? समझ गए यार? Everybody got this point? कि you will feel कि sir, how is that possible? When we are solving this question, कि E is equal to H nu is equal to E H C by lambda. So this formula is also correct. ये भी तो सही है, क्या दिक्कत है इसमें? In atomic structure we use the same thing. In modern physics we use the same thing. Here we are using energy absorbed by the system by photon. Energy absorbed by photon. Photon energy we talk about in this. Here we are talking about emissivity in this chapter of thermal property of matter. And emissivity directly depends upon the temperature. Emissivity is different thing from the energy. And here it is the energy emitted, not absorbed. Here it is energy emitted, not absorbed. So both are different things. अच्छा है था?
ಹೌದು ಸರ್, ಅರ್ಥ ಆಯ್ತು.
Yeah.
सर नहीं समझ में आए तो क्या बोलूं?
इल्ला.
बस उतना ही.
हाँ. नहीं आया?
नहीं आ गया, बट फ्यूचर के लिए पूछ रही थी.
ओके. ऐसा मौका ही नहीं देंगे कि ऐसा बोलना पड़े.
हाँ.
You will never get chance to say like कि सर समझ में नहीं आया. You can say कि सर अर्थ आगिल्ला. Am I right, Chandana?
Yes, sir.
This is the better version. सानिया एंड अर्पित, तुम्हें समझ में आ रहा है ये कौन सी लैंग्वेज की बात कर रहा हूँ मैं?
नहीं
सर तमिल.
नहीं, मैंने ये खुद की लैंग्वेज बनाई है. माई ओन लैंग्वेज.
वाह.
दीपक लैंग्वेज कैसी लगी?
कुछ भी सर.
చాలా బాగుంది सर.
क्या?
చాలా బాగుంది सर.
चाला बाऊंगी मतलब?
बहुत अच्छा.
चाला बाऊंगी उड़िया में है
सर
ये, या तुमने भी अपनी
सर ये
लैंग्वेज बनाई
तेलुगु में, सर तेलुगु में बोलते हैं.
है? बाय द वे मैं कन्नड़ा बोल रहा था, ठीक है? इसलिए चंदना हंस रही होगी कि सर कुछ भी. राइट चंदना?
What, sir?
वर यू लाफिंग सर? सर यू मेड योर ओन लैंग्वेज. I told them whatever I was saying, Artaita, Aitu, Artagilla, this is the language I created. Like I made this language. Deepak's language. and they
Yes.
felt कि yes sir, we accept कि you are right. Okay, so this is the difference, guys. E is equal to h nu is equal to hc by lambda is the energy absorbed when photons strike on the surface. है ना? Energy absorbed, then photoelectric effect will happen. Correct. That's why you will study this equation in photoelectric effect. Correct. This is the energy emitted by the surface, and energy emitted mainly depend upon the temperature. अगर तुम टेम्परेचर बढ़ाओगे तो एनर्जी भी इंक्रीज होगी. और जैसे अर्पित ने पूछा कि सर इफ यू हैव 3 लैम्डा 250 500 and 1000 where we will have maximum emission. So answer is if lambda is less then temperature will be more, and if temperature more emissivity will be more. Right, Arpit?
हाँ
करता है था
आइए।
I do. हाँ. So this is the topic, and you will feel this sir कि sir not able to solve all the question. Absolutely fine, but अभी at least we are spending time ना. हम टाइम दे तो रहे हैं, समझने की कोशिश तो कर रहे हैं, लीव तो नहीं कर रहे टॉपिक को कि अच्छा मुझे नहीं समझ में आएगा, आई वांट टू लीव. वी आर नॉट लीविंग दैट, वी आर ट्राइंग टू अंडरस्टैंड. Okay. Translation energy we have to do. Pressure we'll do later. Temperature of hot bath to bulb, gas bulb. Pressure we'll do later.
22 वाला कर दीजिए फिर
22.
हाँ मेरा गलत आ रहा था इससे.
हाँ, तो pressure versus temperature graph of ideal gas is shown. What is the wrong statement? Though it is given the kinetic theory of gas, but हम कर लेंगे, no issue. So in this 22 we know PV is equal to nRT. Okay, and if pressure in first graph is increasing and temperature is here constant, correct? At constant temperature what is happening? Pressure is increasing. If pressure increasing, volume will decrease, and if volume decrease, density will increase, right? So pressure increase, density increase in the first situation, right? So this is correct. Second, in graph to density, let's see, temperature increases but pressure is same. If pressure is same, then Charles law V directly proportional to T. So if temperature is increasing, volume will also increase, density will decrease. This is also correct. Third, pressure is directly proportional to the temperature, Gay-Lussac law. And you know, when temperature increasing, pressure increasing, density will also wait. Here volume is constant, right? And if volume constant, then density will also be constant. So all are correct. No one is wrong. Yes or no?
And none of these होगा.
None of these. Why? Because
No,
in first case, temperature constant, so Boyle's law. First case, Boyle's law. Second case, temperature is increasing but pressure is constant, Charles law. Third case, pressure directly proportional to temperature, Gay-Lussac law. In third case, in Gay-Lussac law, volume is constant. If volume constant, density is also constant, right? Correct. So none of these. Make sense? Perfect.
हाँ समझा.
Anybody have doubt? If no, all of you will solve this question because we already did this. You know, P V gamma is equal to constant. Same question. P V gamma is equal to constant. If such gas temperature, initially temperature T compressed to the half of its initial volume. So initial volume V, second volume V by 2. Initial temperature T, what will be the new temperature? This is what you have to calculate. Old volume V, new volume V2. Old temperature T, what is the new temperature? I will not explain this question because you have equation PV is equal to gamma. You can, instead of pressure, PV is equal to nRT. So instead of pressure, you can write nRT by V, correct? So nRT by V, and here V gamma. This is 1. So it will go up. So can you say TV gamma minus 1 is equal to constant? Correct? Now you have to solve and tell me answer. All 4 of you. And Arpit, you will tell me in the end. सबसे आखिर में बताओगे तुम.
ओके सर, ओके।
तब तक तुम कोई और क्वेश्चन सॉल्व कर सकते. You can solve question number 20.
20 तो देखते देखते ही हो गया। 20 वाला इजी है।
हाँ, बट 1/p है,
मतलब
याद
पी की
रखना.
जगह 1/p लिखा है। हाँ, तो डायरेक्टली प्रोपोर्शनल हो
हाँ
जाएगा, डायरेक्टली प्रोपोर्शनल हो जाएगा।
हाँ. तो तब तक 25 ही निकालो तुम.
25 तो ये भी तो
थ्योरेटिकल क्वेश्चन.
आरएमएस का जाता है। हाँ, ये भी इजी। ऑप्शन दो राम।
हाँ. Guys, tell me answer.
25
सानिया.
में दो होगा ना, 25 पे।
25 का, हाँ, सेकंड.
हाँ
मोस्ट प्रोबेबल मिनिमम वेलोसिटी. Those are theoretical question.
हाँ, मैंने राम से याद रख लिया, राम से।
Ram. Like
हाँ
many people use this trick. Ram. RMS maximum, then average, then most
हाँ।
probable. हाँ. Chandana, Anvita, Sania, tell me your answer for 24th question.
सर मेरा
Sir,
ऑप्शन 1।
3.
3. Okay, Sania.
सर मेरा 1 आ रहा है।
1. Anvita.
सर एक मिनट।
अर्पित, तुम्हारा क्या आया था?
4।
4th आया था 24th का.
हाँ, नहीं 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 सर, थर्ड थर्ड थर्ड, सॉरी सॉरी सॉरी। लिखा है तो ठीक लिखा है, मतलब गलत तो से बता।
मैं सोच रहा हूँ कि ये कहाँ से कहाँ हो गया.
नहीं नहीं नहीं, मैं दूसरा एक देख रहा था।
तो
थर्ड लिखा है था।
अब तुम्हें यहाँ पे कंपैरिजन करना है. T1 is T. V original will be gamma value is 3/2. So V 1/2 is equal to new temperature you have to calculate T dash, and new volume is V by 2, 1/2. So T dash will be equal to T V by 2 will go into denominator, 1/2, V cancel. So 2 under root, 2 under root. See. Any doubt? Direct. T1 V1 is equal to T2 V2. You have to put values. Gamma value is given. Direct. Sania, कोई doubt? Anvita?
No, sir.
नहीं
हाँ, ये हाँ
31 वाला
31. PV diagram of a gas of a cyclic ABCDA, where P is the unit of pressure, V is the unit of volume. Identify the incorrect statement. This is P2, V2, P1, V1. Tell me, is work done positive or negative? By the gas or on the gas?
Positive.
Anwar? Let's go. Let's go. Work done is positive. Why? Because work done is by the gas positive. Clockwise is positive. Anti-clockwise is negative. Okay. Clockwise is positive. Anti-clockwise is negative. Hello.
ऑप्शन 3
हाँ. Temperature of gas increase in process B2C. B2C pressure is decreasing, right? Volume is same. If pressure decrease, temperature will also decrease, right? Because when volume is constant, T directly proportional to T according to the Gay-Lussac law. So if pressure decreasing, temperature will also decrease, right? So option will be third. Yes or no?
यस यस
Done? Yes. Work done from A to B. A to B will be total area. Okay, like this whole area. So you will multiply 2 into 10 raised to power 10 raised to power 5 multiply by 2 into, yeah, 2 into 10 raised to power minus 6. So answer will be 0.4 joule in A to B. In whole cycle, it will be this part, remember. Whole cycle only this part, not blue one. So pressure will be 1 into 10 raised to power 5 and volume will be same 2 into 10 raised to power minus 6. So answer will be 0.2. So 1 and 4 are correct. C to D, same. You have to consider this area. This this is also correct. So this is the opportunity you understand कि कैसे वर्क डन की वैल्यू चेंज होती है जब सिचुएशन चेंज हो. How work done value change when there is a different situation. Example, A to D and B to C, work done is 0. Why? No change in volume. Change in volume 0. You know, work done is equal to P delta V. If delta V is 0, then work done will also be 0. Correct? That's why from B to C and A to D, work done will be 0. Correct? Total work done, cycle area. How to calculate total work done? Like here, area of the cycle, like rectangle. Correct? Um, yes. So question number 32. System is taken from 1 to 2 along path 1 to A, then 2, and it absorbs 50 calorie heat and work done is 20 calorie. Along path 1B, then 2, it absorbs heat 36. What will be the work done? Chandana, tell me, during this process, what will remain same? Chandana, in this process, what will remain same? From 1 to 2 through A and 1 to 2 through B.
Yes.
Internal energy. You know, in the uh, in- internal energy is a state function. It does
ऑप्शन
not
फोर होगा.
depend upon the path. It is state function does not depend upon path. So, what is the internal energy in first equation? You know, delta Q is equal to delta U plus work done, right? So, what is
हाँ.
internal energy value? Delta Q minus work done. Delta Q 50 minus 20. 30 is the delta U value. Second situation, how to calculate delta Q is equal to delta U plus work done. You have to calculate work done. Delta Q minus delta U. Delta Q 36, U 30. Answer will be 6.
36 तो सर क्वेश्चन में भी दे दिया था.
36 क्वेश्चन में भी दे दिया था.
हाँ.
समझ में नहीं आया, दोबारा बताओ.
नहीं, जो 36 लिखा ना डेल्टा क्यू, तो क्वेश्चन में भी दिया था.
हाँ
क्यू इज इक्वल टू 36.
हाँ हाँ, फिर वही तो हमने अप्लाई किया ना. हमने फर्स्ट वैल्यूज का यूज करके 50 एंड 20 वी कैलकुलेटेड डेल्टा यू वैल्यू. देन वी अप्लाइड दिस इन सेकंड इक्वेशन.
हाँ हाँ हाँ.
गॉट इट.
हाँ.
And if you don't want to calculate, you know delta U is equal to delta Q minus work done. और डेल्टा यू दोनों में सेम है, तो Q 50 minus work done 20 will be equal to 36 minus work done we have to calculate. You do this method.
हाँ.
Correct?
हाँ हाँ.
You will get the same answer. Correct? It's your choice. This was one of the easiest questions. First law of thermodynamics. You have to remember key internal energy is a state function does not depend upon path. If you go by A method or you go by B method, internal energy will be same. Let's do last question of this session. बहुत हो गया. What is the magnitude of the work done in the cyclic process?
ऑप्शन 3.
Option 3.
हाँ.
How?
ये तो एरिया निकलना है ना।
You have to calculate area of the circle. You know, area of the circle is pi r square. Hello, hello. हाँ मित्र, गरा. हम्म. गुड क्वेश्चन. वेरी गुड क्वेश्चन. कहाँ है? ठीक है. ठीक है. ओके. ना अब खत्म करूँ. ठीक. हम्म. So here pi r square is the method because I said if you have to calculate work done, how to calculate area under PV? What is the area? Pi r square. But here both r value are not same. Okay, both r value are not same. Example, this r value will be different from this r value because one is the volume version, second is the pressure version. So if you calculate one r1 value, what will be the value? P2 minus P1 is the total distance between these two. Half will be P2 minus P1 divided by 2. This value total is 2R. So what will be the R2 value? Total 2R value is V2 minus V1 divided by 2. Now you put formula directly. Pi R1 to pi R1 value V2 minus P1 by 2 and R2 value V2 minus V1 by 2. Ask me your doubt. Yes or no, Anvita? Hmm.
हाँ सर.
Any doubt?
नहीं नहीं.
सर
Chandana?
R2 और R1 डिफरेंट होंगे.
हाँ, because R2 R1 different नहीं होंगे, but we are using different axis, है ना? Usually what we do, कि if you take any circle, you see कि radius is same in a circle. That's why R1 R2 is same, and we write formula pi r square. But if these value are different, then what will you do? Pi R1 R2. Got it? Now you have to calculate R1 R2 value. Okay. So this will be 2R1, this will be 2R2, these two. Okay. Take half of their value. Get the answer. Got it? Are we done with most of the question?
अभी
Not
बाकी
yet.
है 3-4 बाकी है 4-5.
हाँ, वेन displacement law, but easy question बाकी है, more theoretical question you have.
हाँ ये चीज है.
ठीक है. So we will not take more than, let's say, 20 minutes to finish this topic. Okay. तो आज के लिए इतना ही. This is enough for today. What you have to do, send me your notes right now in the group, whatever you did during class. जो भी तुमने क्लास में लिखा वो अभी ग्रुप में भेज दो.
So can you send this PDF?
Yeah, sure. So guys, tell me, how was this session, Arpit?
हाँ अच्छा।
समझ में आए सारे क्वेश्चन?
हाँ भेज दिया सर।
भेज दिया। अनविता?
सर क्वेश्चन नंबर 14
तो
थोड़ा देखेंगे, मैं दूसरे मेथड से किया है।
14?
हाँ हाँ मैं भेजा है ग्रुप में, देखिए।
ओके।
ये भी सही है।
डेल्टा टी बाई टी, रेट ऑफ कूलिंग।
नहीं, सी को कांस्टेंट लिखना भूल गया। सी को
हम्म।
देन
ओके, मैं देख लूँ ग्रुप में किस किसने भेजा। अर्पित, सानिया। क्वेश्चन नंबर 14 ऐसे ही तो किया तुमने, बस तुमने सी एक्स्ट्रा लिख दिया।
नहीं नहीं नहीं, सी नहीं, मैंने ए बाय एम रेशियो निकाल कर, रेट रेशियो निकाल कर किया।
हाँ, चंदना एंड अनविता, सेंड योर नोट्स।
ये भी ठीक है ना?
हाँ, who left? Oh, there are 4 people. तो अनविता,
हाँ सर।
अब लग रहा है कि डेली फिजिक्स हो रही है क्लास में तो अच्छे से।
हम्म मेरे को बहुत प्रैक्टिस नहीं है अभी, बट हाँ वैसे अच्छा लग रहा है।
बट क्लास में एक रूटीन बना हुआ है, राइट?
हाँ हाँ यस सर।
चंदना,
Yes, sir.
you are getting practice for physics properly every day,
Yes, sir.
but at the same time you feel कि you have to solve more number of questions.
Yes, sir. I have to solve.
Yes, finish all the questions from this 45, and once we finish this, all of you have to send me explanation of 45 questions.
सर केटीजी के क्वेश्चंस भी करने हैं? नहीं तो
अभी के हाँ, तुम कर सकते हो,
हाँ हाँ कर दिया हूँ।
because in tomorrow class we will start KTG. KTG will finish in 2 class.
3 ही तो
सानिया,
फॉर्मूला है।
यस
करेक्ट, 3 ही तो फॉर्मूला है। प्रैक्टिस हो रही है अच्छे से क्लास में फिजिक्स की,
हाँ सर।
और ऐसा लग रहा है कि वैरायटी ऑफ क्वेश्चन 3 चैप्टर एक ही बार में हो रहे हैं साथ साथ में।
यस सर, प्रैक्टिस तो हो रहा है।
क्लास में कितने दिनों में होता है एक चैप्टर कोचिंग में?
एक चैप्टर अभी तो थोड़ा फास्ट चल रहा है,
हाँ,
फिर भी 2 वीक्स।
15 दिन लग जाते हैं।
थर्मोडायनेमिक्स 15 दिन।
हाँ, तो मतलब 1.5 महीना लग जाता है चैप्टर, 3 चैप्टर में तो है।
यस सर।
हाँ, ये थर्मोडायनेमिक्स।
यही प्रॉब्लम है, यही है,
हमारे
क्या
इधर तो
करें।
पढ़ाई के अलावा सब कुछ होता है ऑफलाइन में।
जैसे
पढ़ाई के अलावा सब कुछ होता है,
बस पढ़ाई
पढ़ाई
नहीं
नहीं
होती।
होती। नहीं नहीं।
आ, यही है ऑफलाइन की मतलब दिक्कत, क्योंकि टीचर आते हैं ना, मतलब दिक्कत तो कुछ नहीं, लेकिन स्पीड की थोड़ी सी इश्यू है, मैंने सुना है ऑफलाइन के सारे सेंटरों में, मोस्टली कोचिंग इंस्टीट्यूट में।
हाँ हमारे इधर टीचर नहीं है ना, टीचर ऑनलाइन में पढ़ाते हैं, यही तो दिक्कत है।
अच्छा, हाँ, तो तुम्हें अभी ऑफलाइन में जा रहे हो?
नहीं नहीं नहीं, मैंने छोड़ दिया, मतलब ज्वाइन हूँ, उनको पता ही
हाँ,
नहीं होगा मैं उनका स्टूडेंट हूँ कि नहीं, मतलब।
वैसे सही कर रहे हो, तुम नहीं जा रहे हो, क्योंकि वही बात है, उससे ज्यादा प्रोडक्टिविटी तो यहाँ पे निकल जाएगी।
हाँ, मैं सुबह ऑनलाइन क्लास कर लेता हूँ क्वेश्चन प्रैक्टिस के साथ, आप उसके बाद
हम्म।
एक क्लास के साथ मैं रात में
बस,
फिर।
करेक्ट। बट एक बात मैंने सारे बच्चों को पहले भी मेंशन की थी, आई हैव मेंशन वन थिंग फॉर ईच एंड एवरी पर्सन। जस्ट गिव मी अ मिनट। हेलो। हाँ जी। तो 10 मिनट दे, ये क्लास के बस खत्म कर। हाँ, क्लास खत्म करूँ, चाह रहा हूँ। हाँ, ठीक है, आगे। हाँ, सो रिमेम्बर वन बेसिक थिंग, वन थंब रूल, कि इफ यू आर एवरेज स्टूडेंट। अन्विता, डू यू रिमेम्बर, मैंने ये बात बोली थी 2-3 बार,
क्या बात सर?
कि इफ यू आर ए एवरेज स्टूडेंट, you will you will do your task on time, right?
हाँ।
हाँ, so this is the basic mantra guys for everyone। ये सिंपल सा मंत्र है सभी के लिए, कि इफ यू आर ए एवरेज स्टूडेंट, तुम अपने टास्क टाइम पे करोगे, यू विल डू योर टास्क वट एवर विल बी गिवन। इफ यू आर ए बिलो एवरेज स्टूडेंट, you will not finish your task on time, whatever is given to you in group। ठीक है। And if you are extraordinary student, if one student task is given to you, you will do two। अगर तुम्हें कम काम दिया जाएगा, तुम ज्यादा करोगे। दिस इज हाउ एक्स्ट्राऑर्डिनरी पीपल डू। एनीबडी यू सी इन द एनी अरीना, एग्जाम्पल पॉलिटिक्स, तुम्हें लगता है कि पॉलिटिशियन लोग एकदम लूट रहे हैं लोगों को, यस, दे आर लूटिंग। बट ये भी देखना कि जब इलेक्शन होते हैं ना, तो 20-20 घंटे काम करते हैं वो 6 महीने तक, 1 साल तक, है ना। स्पोर्ट्स पीपल आर अर्निंग इन CR एवरी डे, क्योंकि विराट कोहली जैसा इंसान फील्ड पे अगर 9 बजे जाना है ना, तो 7 बजे जाएगा, है ना, 2 घंटे एक्स्ट्रा प्रैक्टिस करेगा। सेम फॉर मेनी पीपल लाइक रोनाल्डो एंड मेनी मोर। तुम्हें पता है ये, कि एक्स्ट्रा ऑर्डिनरी पीपल डू वर्क मोर देन व्हाट दे आर सपोज टू डू, इसलिए वो एक्स्ट्रा ऑर्डिनरी। नाउ यू हैव टू इवेलुएट योरसेल्फ, कि इफ यू आर एवरेज स्टूडेंट राइट नाउ, तो 50-50% you will get seat or not। if you are below average, as of now there is no chance। मतलब इस मोमेंट में तो कोई चांस नहीं है कि उसका सिलेक्शन हो जाएगा। जिसको टास्क दिया गया उसने कंप्लीट नहीं किया, 100% सिलेक्शन नहीं होगा, मैं लिख के देता हूँ। ठीक है। बट यू कैन चेंज, लाइक यू कैन चेंज दिस सिस्टम। बट पीपल जिनको टास्क दिया गया उन्होंने एक्स्ट्रा किया, पीपल हु आर डूइंग एक्स्ट्रा थिंग, दे विल 110% get selected for the NEET exam। This is the basic thing। Now you have to frame yourself, कि तुम बिलो एवरेज देखना चाहते हो, एवरेज या एक्स्ट्रा ऑर्डिनरी। एम आई राइट, सानिया?
Yes, sir.
मेक सेंस?
Sure, sir.
चंदना?
Yes, sir.
सो अन्विता
यस सर।
एंड अर्पित, ये बात पहले सुनी है तुमने कभी?
मैं आपने ही बोला था पिछले साल।
पिछले साल ही बोला था मैंने, सेम कहानी।
हाँ हाँ।
मु- मुझे लगा मैंने इस साल नहीं डिस्कवर की है ये स्टोरी।
नहीं नहीं, 2-3 बार बोला है मुझे।
है?
हाँ, ये ज्यादा भी बोला
चलो,
है, 7-8 बार शायद।
अच्छा। या सो दिस इज द बेसिक मंत्र। मतलब तुमने फील किया कि ये चीज रियलिटी में होती है सभी लोगों के साथ, जो एक्स्ट्रा ऑर्डिनरी कर रहे हैं, जो एवरेज है, जो बिलो एवरेज।
हाँ हाँ होता है।
तो अब तुम्हारी चॉइस है, इट्स योर चॉइस व्हाट यू वांट टू डू गाइस। मेक श्योर यू आर एक्स्ट्रा ऑर्डिनरी बिकॉज एवरीबडी इज रीडिंग फॉर दिस नीट एग्जाम। और मैंने आज बोला था आई एम ऑल्सो योर कॉम्पिटिटर बिकॉज आई विल ऑल्सो राइट नीट एग्जाम।
आपका बंदा, आपका तो हो जाता है फिर नहीं जाते आप।
नहीं, फिर कम से कम मैं किसी का सीट तो नहीं खाता ना, उनको दे दिया था।
रैंक तो खा जाते हैं ना, रैंक तो खा जाते हैं सीट के।
हाँ, रैंक खा जाते हैं, फिर वही बात है ना कि इस बार जो मैं एक्सपेक्ट कर रहा था वो रैंक नहीं आया, तो नेक्स्ट टाइम पक्का मैं करूंगा। आज मैं सोच रहा था बैठ के दिन में, बहुत सोचा बहुत सोचा, और मैंने ये कंक्लूजन पे निकला कि मैं तुम्हें बहुत शिद्दत से पढ़ाऊंगा इस साल। ठीक है, आई टीच यू विद लॉट ऑफ एफर्ट, एंड मेरा गोल है कि तुम्हारा सिलेक्शन करवाना। माई गोल इज टू गेट यू सिलेक्टेड इन द नीट एग्जाम, क्योंकि आई वांट टू बी ऑन द नेक्स्ट लेवल। अर्पित, आई एम योर डायरेक्ट कॉम्पिटिटर। है ना? And
हाँ
for chemistry and physics, like I'm doing only mostly JEE segment, not NEET at all.
हाँ, मैं भी जेई कर रहा हूँ, जे एडवांस एडवांस ही कर रहा हूँ, नीट छोड़ दिया
हाँ
इजी।
हाँ। अब मैं क्या कर रहा हूँ कि तुम लोगों को पढ़ाता हूँ तो नीट लेवल का पढ़ाता हूँ, जब खुद पढ़ता हूँ तो जेई मेंस और एडवांस का ही क्वेश्चन प्रैक्टिस करता हूँ।
मेंस भी तो इजी आ रहा है ना अभी, एडवांस ही करना है, सही रहता है।
हाँ, मेंस इजी आ रहा है, बट मेंस बहुत अच्छा लॉजिकल पार्ट है, कि एडवांस करने का अभी बेनिफिट ये नहीं है, क्योंकि एडवांस क्वेश्चन आएंगे ना, उनमें टाइम ही इतना लगता है कि आप कर ही नहीं सकते।
नहीं,
समझ
प्रैक्टिस
रहे
से
हो?
तो वो भी स्पीड ऑफ हो सकता है ना।
हाँ, स्पीड अप हो जाएगी, बट मतलब वो क्वेश्चन ही इतने लेंथी होंगे तो तुम उनको अटेम्प्ट भी करोगे तो टाइम ही खत्म हो जाएगा। बस मेरा जो ये ओपिनियन है कि जेई मेन से क्वेश्चन लगाओ, और अच्छे से लगाओ, क्योंकि उसके काफी ट्रिकी क्वेश्चन होते हैं, उससे स्पीड अप हो जाएगा। एडवांस के लगा सकते हो अगर यू हैव टाइम, बस ये मेक श्योर करना कि टाइम इतना ना चला जाए कि और क्वेश्चन के लिए टाइम ना मिले।
नहीं, हमारे सीट में सिलेक्टेड देते हैं सर, प्रैक्टिस सीट में
हाँ,
सिलेक्टेड देते हैं एडवांस क्वेश्चन, उसको ही लगाता हूँ।
ठीक है। तो 12, 13, 19, चंदना, you solved 3 questions. Your voice is breaking, Chandana. Your voice is breaking. तो इस बात का ध्यान रखना कि मैंने आज भी सोचा है कि अच्छा, यू सेंड मी वन मोर। ओके, तो आज ही सोचा है कि नीट को थोड़ा सा मेहनत के साथ लिखा जाएगा, अभी स्टार्ट करना है मुझे चीज प्लान करके। एंड 18, 19, 20, तो इट्स गोइंग टू बी टफ, रिमेंबर, यू हैव टू टॉर्चर योरसेल्फ, है ना? टॉर्चर मीन्स you have to compromise something to read every day. कुछ फ्रेंड भी बाहर जा रहे होंगे, तुम्हारा भी मन होगा, बट इफ देर इज ए क्लास एंड इफ देर इज ए क्लास और टास्क गिवन, वो टाइम पे करना है, ओनली देन यू विल बी एबल टू सिलेक्ट इट। ठीक, बस दैट्स द नॉलेज फ्रॉम माय साइड। टू मच नॉलेज वेरी डेंजरस। गुड नाइट।